In Indonesia, the Blacksmith Institute is working to prevent mercury pollution along the Barito River in the province of central Kalimantan. Here, in the area known as Mt Muro, a local community development foundation, the Yayasan Tambuh Hak Sinta, is introducing appropriate technology to prevent the release of mercury from small-scale gold mining. We're in the village of Mangkohoi, which is a Dayak village. It's a traditional village, but this end of the village has been filled entirely with processing sheds. So you can see the processing going on the left and on the right. When we first came here, there were retorts burning along the street, these homemade retorts, which were very inefficient. So this was incredibly contaminated. But now, fortunately, they're all using these much more efficient retorts. So we've managed to reduce the contamination in the air dramatically, and it's a lot safer to stand around here. These sheds are amazing because they're all handmade, basically. The carpentry is all done locally. They have a wooden shaft there on some bearings which rotates the entire set of drums. The drums rotate for 12 hours together with the tungsten bars that are inside, and the tungsten bars smash up all of the rock, pulverize it into sand. Then they open it up, they wash out the mud, and then they pulverize it further for another 12 hours. All of this happens with mercury inside the drum. So the mercury also gets pulverized. Now the unfortunate thing is the mercury becomes very, very fine, and a lot of it gets washed out with the tailings and gets lost. Now what he's doing is he's putting the amalgam into the retort. He's spreading it around the base of the retort so that it will evaporate more easily, and then he'll close it up. This is a retort that'll take about up to 1 kilo of amalgam quite well, and it's a small retort. We also have much larger retorts. So we've had good adoption with the small retorts and also with our large retorts. Over the course of this project, we've distributed about 100 retorts so far. Here we have gold and silver as doré. 3/4 of the amalgam was actually mercury, so that the retort captured all of that back again. There are very good reasons why people use mercury here. The gold grain size is very fine. Mercury is extremely effective at capturing it, and finding a substitute, an alternative for that is very difficult. Obviously you can go back to gravity separation techniques, but they need to be time and cost efficient. We've had a lot of success with our recycling technologies, and we've been trying to introduce sluices as a way of recycling the mercury from the tailings as well. And ultimately this increase in price in mercury is certainly going to boost people's willingness to start recycling more and more, and to try alternatives to get the mercury out of the tailings, for example. At first, whenever you go to a new location, people are suspicious of your intentions, but if you bring them retorts and they find those very useful, as they do, then they quickly gain trust in you, and then you can move to other processes like this to have more in-depth investigation of the tailings issue. So here we're trying to show to the miners what they're losing in floured mercury. And we met somebody yesterday who recovered 6 kilos when he relocated his tailings using a sluice like this. So it is possible to capture quite a bit of mercury. We were hoping that we could just do a mercury-free process, in which case we'd be catching gold right now. However, the trommels are so contaminated with mercury that even if they stop using it, it still comes out for a protracted period. So it's quite difficult to introduce this and to just catch clean gold straight away. Mercury is released into the environment both as a gas whenever amalgam is burned, and as residual mercury that is left behind in the tailings. When the tailings are released, these fine particles of mercury can often find their way into waterways, creeks and rivers. So this is a little tailings dam which is holding the tailings, the secondary ore after the processing and reprocessing, and probably they'll eventually take this away to a cyanide vat, but if it's just low grade, it might just be released into the river. Here we have the cyanide vat, and it's a stirring vat which takes several days to complete. So this is a major source of mercury contamination because we've studied the problem of the amalgam. We know that double the amount of mercury goes into the tailings than goes into the amalgam. So we calculated 30 tons of mercury per annum goes into the amalgam here in Mt Muro, but we've calculated that 60 tons per annum goes into the tailings. So of that, very little is being recovered, and it's all being lost in this manner as it washes out of the cyanide vat in the end in a very soluble form. So we're all set up now to do some tests, and we're going to use samples taken from the tailings over here. These are mercury contaminated samples, but we're going to run them anyway to try and extract the mercury from them. So we'll weigh them first and use 15 kilos of material. We'll run it on the table and we'll see how much mercury we can get from those 15 kilos. Yeah. The front line is all very fine particles of mercury, and the back line is black sand. But what we're interested in here is the mercury. So actually we're extracting the little bit of mercury that was very, very fine and particulate and spread throughout the material, and we've actually concentrated it into a line, and we can get it very easily. In addition to these technical interventions, the program is also reaching out to the local community to educate them about the dangers of mercury exposure. Tumbuh Sehat means grow up healthy, and it is a campaign designed specifically for women and children, as they are the ones who are most at risk from environmental contamination. As more and more of these people begin to understand the danger that surrounds them, they will be more able to influence the miners to change their behavior. We're really hoping to eliminate mercury use here in Mt Muro if we possibly can. It's a long journey to take. We may have to move through stages. First through the amalgamation of concentrates possibly, and possibly the total elimination of mercury using the shaking table. And for the miners themselves, there'll be very good economic benefits. If we can increase the recovery, there'll be economic benefits for the miners and for the whole community. But then there's also health benefits for the mercury users themselves, and for the children and for the women in this community. And lastly, there are environmental benefits for all those downstream from here and for the global community.